Compute the sum of all positive integers n for which the expression n plus 7 over square root of n minus 1 is an integer. Okay, so let's take a look at this, and we want this expression to be an integer. And first of all, that means that this denominator has to be rational, because if it's irrational, like for example, if n equals 3, then you'd have something like 10 over square root of 2, which is clearly not an integer because it's going to have some square roots in it. So we need square root of n minus 1 to be an integer as well, which means that n is equal to a squared plus 1 for some integer a. Okay. So if we substitute this thing into this expression, you're going to get n plus 7 is a squared plus 1 plus 7. And the square root of n minus 1 is square root of a squared plus 1 minus 1. This is equal to a squared plus 8 over the absolute value of a, right? Since we're taking the principal square root in the denominator. And well, notice that you have this a squared here. It's always going to be positive no matter if a is positive or negative. You have this absolute value of a, which is always going to be positive no matter if a is positive or negative. And note that a can't be 0, otherwise you're dividing by 0. And so since everything here about a is positive, we can just assume that a is positive, because if a is negative, like for example, if a was equal to 1 and a is equal to negative 1, this expression wouldn't change, and n wouldn't change either because n is a squared plus 1. So we can just assume that a is positive, right? A greater than 0. And this expression becomes a squared plus 8 over a. And this is equal to 1 over a times a squared plus 8. And if you distribute this 1 over a, you get this is equal to a plus 8 over a. So 8 over a has to be an integer. And since a is greater than 0, this means that a is a factor of 8, which means that the possible values for a are 1, 2, 4, and 8. Now remember, we wanted n, which means that we're going to need to sum up all possible values of a squared plus 1. So when a is 1, n is 1 squared plus 1, which is 1 plus 1 is equal to 2. When a is 2, n is equal to 4 plus 1 is equal to 5. If a is 4, n is equal to 16 plus 1, which is equal to 17. And when a is 8, n is equal to 64. 8 squared plus 1 is equal to 65. And if you sum up all of these possible values for n, you get 2 plus 5 plus 17 plus 65 is equal to 89. And this is our final answer, so we are done. Thanks for watching, and I will see you next time.